oxyacids. And for many, this is the most difficult ones that we'll be naming. So if you've been struggling up till now, you'll probably struggle more, but we'll do our best to help you out with these. These here, these always carry their acid name. So in other words, we don't need to worry about when oxyacids are dissolved in water or not dissolved in water. They're always named by their acid name. And to name these, what we do is we identify and name the anion present. In the acid. And then what we do is we drop the ATE suffix from the anion name, and then we replace with the suffix of IC acid. Now, of course, in an oxyacid, which element is always going to be present? Oxygen. And because it's an acid, hydrogen will also be present, and hydrogen is going to be written at the front of the formula. But because it's an oxyacid, it's going to have those anions in there that contain oxygen. Most of those anions we work with end with ATE, but sometimes it will have a suffix that ends with ITE. And if we have one of them that ends with an ITE suffix, what we do is we drop the ITE suffix from the anion name, and we replace that with a suffix of OUS acid. Now, for mnemonic that may help you keep it straight, use this: I ate something icky. I ate something icky. Or you could look at it like this: 8 comes before "ite," just like IC comes before OUS. So it's alphabetical. 8 before "ite," 8 before OUS. So then, to come up with the names, let's say that we have these two acids here, HNO3 and HNO2. We want to come up with names for these acids. Now, when working with the oxyacids, I like to use what I call the four-square method. And I made it up so I can call it whatever I want. But what we're going to do here is we're going to name these using the four-square method. We're going to kind of do it sequentially like we're showing here in the description. So the first thing we're going to do is we're going to identify the formula of the anion. So we get rid of the hydrogen, and the formula of that anion is going to be NO3 with the charge of 1 negative. Well, it's just a single negative, so it's going to be NO3 with a negative charge. And in this one here, formula is going to be NO2 with a charge of 1 negative. And you can get the charge on that simply because, remembering that the hydrogen always has a charge of 1 plus, if we have one of each, then the charge in this one must be 1 minus. That would be, even if you didn't memorize this, this would be an easy way to work backwards to get it. So then, to name these ions, what is the name of this one here? This is the nitrate ion. This one over here is the nitrate ion. So then to come up with the name of the acid, what we're going to do is we're going to drop the ATE suffix from the anion name and replace it with IC acid. So this one, first one here becomes nitric acid. Nitric acid. And the second one here becomes nitrous acid. Yes, nitrous acid. So again, we can see that spelling counts here. Nitric acid versus nitrous acid. Now, as I always tell you, if you have any questions, just raise your hand. If you don't have any, we'll keep going here. Let's go the reverse direction. Let's say that we have carbonic acid, and we want to write the formula for this. Going in the reverse direction, carbonic acid must be derived from which anion? The carbonate ion, yes. And the carbonate ion now will be one of those ions you were to have memorized. Right, it's right here. It's CO3 with a 2 negative charge. CO3 with a 2 negative charge. Then to make an acid, we combine it with which element? That element is hydrogen, and the charge on hydrogen is always 1 positive. So there's that charge. Then to write the formula, it would be H2 CO3, because we need 2 hydrogens to balance the charge of the 1 carbonate. Let's try another one in reverse here. Let's look at chloric acid. Chloric acid has an IC acid suffix. With an IC acid suffix, that must mean that this is derived from the chlorate ion. And the chlorate ion is one of them that we should have memorized, that has a formula of ClO3 with a single negative charge. That's this one right here. Then to write the formula for the acid, we combine it with H plus. So the formula would be HClO3. Now remember that we already looked at the formula for hydrochloric acid, and hydrochloric acid had a formula of HCl. Okay, and so here's this important distinction between them. Remember that if it's a binary acids always have a hydro prefix on them. This one here does not have the hydro prefix on it. There's no hydro prefix that makes it an oxyacid, and an oxyacid will always contain oxygen, but because it's an acid, will always have hydrogen written out at the front of the formula. Which then takes us down to our last 2 examples here that we're going to look at. And it turns out that there are 2 elements that have different root names in anions and acids. And I think that the reason for this is that there were some of compounds that were named in an organic chemistry convention that we couldn't duplicate names, so we had to come up with a different way of naming these, which is why these wind up with different root names for inorganic compounds. And those 2 elements are sulfur and phosphorus. And so what I'm going to do here is I'm going to make a small table and look at the root name in. One of them will be the root name in acids. No, not acids. I think we'll start with anions. So that's what we've been working with. And then the root name in acids. So anions is what we've been working with up to now with these root names. In the case of sulfur, what is the root name of sulfur? So it's going to be S-U-L-F, because we have sulfate, sulfite, sulfide. And in the case of phosphorus, it is phosp. So we had phosphate, phosphite, phosphide. But now in acids, it's going to be sulfur and phosphor. We add on an additional syllable when we name them as acids. And that's because it turns out there's such a thing as phosphate acid, which is not going to be how we're going to derive it here. And so there is some confusion, and that's something that's found in organic compounds. And so again, we probably have these rules to avoid duplication of names. So then, if we took something like H2SO4, and we want to write out the name of this compound, here's what we're going to do. First of all, let's write out the form. We're going to use the 4-square method because this is an oxyacid. It's an easy way to do it. We'll cover up the hydrogen. That tells us that the formula of that anion is SO4 with a charge of 2 negative. So it's SO4 with a charge of 2 negative, which we've memorized as the sulfate ion. If you haven't memorized yet, this is where you're getting a little behind. Here's your sulfate, SO4 with a 2 negative charge right here. So then to name the acid, what we do is we drop off the ATE suffix, replace it with ic, which is IC acid. But we also have to change the root name from sulf to sulfuric. Yes. The root name is sulfur, but this then becomes sulfuric acid. So again, notice the change from sulf to sulfuric. And we only change that root name when we're working with the elements sulfur and phosphorus. And sulfuric acid is the acid found in car batteries. If you have lead acid storage batteries, that acid that's in there is sulfuric acid.